Hey, neat people, welcome back. We're gonna do some more special products, and this is one of my favorite ones to do. If I see this one, I get really tea time. We gotta hurry up. Okay, this is one of my favorite ones. I recognize them like, ooh, yes, that's his dots. It's the difference of two squares. So to show you what this one looks like, and if you recognize the form, then you can take the shortcut to the answer. That's what's so great about these. So we're going to play the same game as we did the last time. We're going to start off with a pattern. We're going to see if we can recognize the pattern in the products, and then take the shortcut to the answer. So I'm going to start with this here. Before, where we had the signs being the same, now the signs are different. D's for different. Difference, like, well, it's not the same thing, right? D for difference, like subtraction problem. Okay? Because when I do the math here, I get x squared minus 1x plus 1x, and then positive 1 times negative 1. So what happens here in the middle is that all that middle stuff goes away. It cancels itself out, and I'm left with x squared minus 1. If I do this one, I'll get x squared minus 2x plus 2x, and then a positive 2 times a negative 2 makes a negative 4. The middle stuff is the same, but opposite side cancels itself out. You're left with x squared minus 4. You remember from the last one, we're finding here certain patterns. X squared minus 3x plus 3x, and then negative 3 times positive 3 is a negative 9. This number over here on the other side of the minus sign is a perfect square, is it not? So the next one, if we had x plus 3x minus 3, we would expect at the end to have a minus 16, or 4 squared. Let me keep going and just generalize this. A lot of times you see it just says a and b. A squared minus ab plus ab. It doesn't matter what the factors are. They're going to cancel each other out in the middle. And then a negative b squared. And if you take out that middle piece that we don't end up using, you get a squared minus b squared. Or if you got it as a polynomial, factored form here, x squared, and then the middle pieces will cancel out, right? Minus xn plus xn. And then we get negative n squared. So we can go forwards or we can go backwards. It doesn't really matter. If you see something like this, that's perfect square and that's a perfect square, and there's the difference. This is the difference of two squared numbers, or x squared minus 2 squared, or this would be 3x squared minus 6b squared. You can split that up into its two factors. Okay? A squared minus b squared equals a plus b times a minus b. That's our shortcut there. Okay? If we see that it's, well, I guess the way that we did it here was to find the pattern, and that was the middle pieces cancel each other out. We have first thing squared minus the last thing squared. So if you see that in a problem like that right there, as long as you can write that as something squared minus something squared, you can just take the first something plus the second something and multiply that by the first something minus the second something. You could rewrite that in a factored form. Okay? Pull that thing apart into two pieces very easily if you recognize that you have the difference, subtraction, in the middle of two squares, something squared minus something squared. And it has to be something squared minus something squared, or else it will not work. But the middle stuff is going to take care of itself. So this one right here is 5 squared minus 4 squared. I know you can just do the math, right? You can go 25 minus 16 is 9. But let me just show you that the math works here. That would be 5 plus 4 and 5 minus 4 multiplied. That's 9 times 1 is 9. Okay, it works. This one here becomes x minus 2, x plus 2. It doesn't matter which one goes first. There you go. It's split up into its two parts. We already did that one right there. This comes in handy in close together problems. If you want to square things that end in 5, that's really easy. We did that at the beginning of the year. And so we know that 15 squared already is going to be 225. 16 times 14 is close to that. One is up and one is down. So we could treat 16 as 15 plus 1. Or we could treat 14 as 15 minus 1. And then we could just apply the difference of two squares rule and squish that all together. This is the factored form. Why don't I put that in something squared minus something squared form? It's 15 squared minus 1 squared. There's 15 squared, so this is 225 minus 1 is 224. Okay, quickly do the math on these ones. Or, how about 17 times 13? This one's 15 plus 2. This one's 15 minus 2. I can do all the multiplication and mess up a whole bunch of stuff, or I could say that's 225, 15 squared, minus 2 squared, 4. 225 minus 4 is 221. I get the answer super duper quick if I do it that way. Something squared minus something squared. Let me show you maybe 2 more examples and they'll be done for the day here. Well, why keep laughing? You know, it's rude. I'm trying to help you do math, and you're like, were you distracted today? You got digestive problems? I mean, this is serious. This is math. Come on. Okay, a couple examples from the book. 9m to the 4th minus 16n to the 6th. First, you look at that and you're like, how do I turn that into something squared minus something squared? I mean, come on, that's 6. I can't. What do I do with that? Well, it's okay. We can. 9 squared. 9 is a square number. It's 3 squared. And m squared using the power rule, that is m to the 4th. So any even power of a variable, we can split it up into an even or odd number squared. Like if it was a number to the 10th power, that's equal to the 5th squared. Okay? It's an even number of power. We can always split it up like that. Here, that's a square, and this is n cubed squared. So something squared minus something squared equals the first thing plus the second thing times the first thing minus the second thing. And you can verify that by foiling everything back in together. I'm not going to do that. You can hit pause and you can do that on your own to verify, but it's true. You got to believe it. Here's another problem where it's a little bit backwards. But if you notice that if you rearrange the parts and put the variable first and put the number last, it's the difference. Minus sign turns into subtraction. Negative sign turns into subtraction. That's the same thing for our commutative property as this right here. And that is something squared minus something squared, which we can factor down to as c to the 4th plus 8, c to the 4th minus 8. Again, you can verify that on your own, but I'm just following the pattern. I'm going to trust that pattern because it works. So if you're smart, you know, and people won't like trick you or anything like that, and you'll be like, I know that's the difference of 2 squares. That's an easy problem. Okay, we'll see you in class. Maybe you want to ask some interesting questions. I love interesting questions. So thanks for watching, and please subscribe.